Goody. I thought you were in the last class, Ruby. Are you in both classes? Where's chat? There's chat. I'll be right back. I'm gonna get some water. Oh, it's getting hot. How you guys doing? You can turn your microphones on if you want. Failed your TP test, so quarantine is going poorly now. Oh, I'm so sorry. I used to teach that class. Transaction processing. It's, if you've never done coding before, it's a difficult class. Also, from what I remember, because I had Dr. Parks for classes too, from what I remember, he teaches right about here. Right about at this level. I teach right about here. He teaches right here. So unless you're paying attention every second, you're going to miss stuff. Or unless you're really good at learning things on your own, you're going to miss things, and it's tough. But that's kind of on purpose. What we're trying to teach you guys to do is be better researchers, and you can find a lot of this stuff on your own. In fact, a lot of the stuff that I teach, you don't need me. I don't teach you anything that you can't learn on your own on the internet. But some of us need and want structure. I'm not saying you shouldn't. You should just drop out. I'm saying, you know, that you can learn all this on your own. Let's wait a couple minutes to see if anybody else attends. You guys can turn on your video if you want. I like to see people. And you can turn on your audio and talk. There's, how many of you have used Zoom before? So if you've never used Zoom, first of all, can everybody hear me okay? Your first class. Loud and clear, good, because I'm talking loud and clear, first of all. I do have a server in here, so it makes a little bit of background noise. This computer sitting on top of it, but I'm sitting pretty close to the laptop, so you should still hear me okay. This is what my office looks like. I have lots of computers and lots of servers in here. This is my home office. How many people are at home and how many people are at Starbucks? Hopefully nobody's at Starbucks. For those of you that don't know, school is still open. The building is still open. You're still at the dorm. Do they, I'm like you, Jake, I never leave the house either. I guess that's the people named Jake don't ever leave the house. unless we're doing some crazy stuff like skydiving, right? So school is still open for those of you that didn't know that. And I did see some students up there. You still do have access to the EI lab. I'm not requiring you. In fact, I'm going to have to change the lab assignments and maybe, make them just writing reports. I don't know how much of a lab assignment we're going to be able to do and how much of the EI lab we're going to actually be able to use in this class now, especially given the fact that Alina Hidalgo is probably going to shut down the city pretty soon. I'm not trying to scare anybody, but that's just logistically what it's sounding like. And I know there's some students that don't have the appropriate technology. If you guys know of any students that are having issues, like they don't have a decent laptop that will run Zoom, let me know or let them know to contact me, call me. Okay, and yeah, you'll be able to do some of the assignments you can do from home, like the draw.io assignment, which I am going to make an official assignment, not just extra credit. You can certainly do that online because that's just a web app. You don't have to do them on the virtual computers. The only reason we provide those virtual computers in the EI lab for this class is so that we could do experiments on a real lab network. But you can do these same experiments on your home network if you want to. That's up to you guys. What the deliverables from that homework are going to have to be is like screenshots and answering questions. So it's going to basically be you're answering a few questions about the results of your quote unquote experiments that you're doing. So don't have to access the EI lab anymore. And like I said, we'll probably be locked out pretty soon. I'd like to know, first of all, if you've never used Zoom before, Zoom has the ability for you to virtually raise your hand. If you click on the little buttons on the different things you can do, you can mute and unmute your microphones. You can mute and unmute your video. Nobody seems to have their video on. At least I'm not seeing much video. Maybe just my computer can't handle I'm using a little crappy laptop for this because it's got a camera on it. I don't ever have cameras on my desktops. Everybody's microphone is muted. Is that on purpose?
Yes.
Okay. So if you want to ask me a question, moving forward here, either turn your microphone off and ask the question or type it in the chat window, but I may not see it for a minute or two. I'm trying to pay attention to that chat window. What I'm going to do is I'm going to share a screen and go through the PowerPoint presentation on my shared screen here, and then also continue to talk to you guys. But what I'd like you to do is send me an email sometime after class and let me know how your experience was using this, whether you've got some suggestions for me or whether you've got some questions for me other than when is my grade for test 1 going to be up there. I'll get all that in. I've been super busy, as you might imagine, over the last 2 weeks with my clients and with school districts. I'm helping at Fort Bend ISD figure out how they're going to basically deliver curriculum to 77,000 students, 20,000 of which don't have computers. Didn't think about that, huh? Some of you who are students at U of H don't have your own computers. So trying to help them do that. They've got a lot of technology. They just have to figure out how to deploy it and who to deploy it to, and how are they going to get that technology back from those students? How do they reach those students if they don't have a cell phone already, or their parents don't have a cell phone, or they don't speak English? How do they get this technology to these families? So anyway, send me an email with what your questions and concerns are, suggestions. What are the other teachers using other than Zoom? Anybody else using Microsoft Teams? YouTube lectures? Or they're just recording lectures? Okay, so in other words, they're just recording their lectures and you're taking the class asynchronously. Is that what you're saying? And then what are you going to get graded on? Not participation, I guess, just taking the exams. Parks uploaded pre-recorded lectures, which you probably made years ago, I would guess. Or okay. Tests on Blackboard. He made it Sunday. Okay, cool. I give Parks a hard time. I hope it never gets back to him, but you know, I've known Dr. Parks for many, many years. He was my professor back in 1980 something or another. Back when he was younger than I am now. Okay, so I don't remember exactly where we left off because it's been so long, but I think we were somewhere in chapter 7. Just got the grades back for TP. Is that good or bad?
Pretty bad.
Pretty bad. So I guess the TP shortage is real. But okay, anyway. By the way, if anybody needs a TP, let me know. I got some suggestions for you. You can you can use coffee filters. By the way, those work. Or Aldi and Walgreens, or go to the or Trader Joe's. Go to the stores that don't normally. Don't go to the big box stores, guys. Okay, don't go to Costco. Don't go to Sam's. Don't go to HEB. Those places are going to be packed, and they're not going to have what you need. Don't go to Kroger. Amazon sells bidets. Yep. All right, let me share a screen here. I'm lost. Here we go. And you're going to have to bear with me. I haven't used Zoom very much at all either. Okay. So we'll see how this goes. Maybe I'll just start doing this from now on. All right, we were already, I'm pretty sure, in chapter 7 here. Don't remember exactly how far we got. We were just basically talking about the components of a LAN. And so the important things I need you to know from this chapter are what are the components of a LAN and some terminology that we use on LANs. Let me make this screen bigger. Hang on one second. Oops, no, too big. Let me reopen my chat window. Okay, let's leave the TP talk behind. The toilet paper and the transaction processing talk. Let's leave it behind. No pun intended, excuse me. Okay, so we were talking, I think we were somewhere around access points. Everybody knows what an access point is. And in LANs, the most common, or the newest technology that I see on LANs and the newest changes I see on LANs is all to do with wireless. In fact, a lot of companies are not even installing any LAN cabling anymore. It's all 100% wireless. Not just for the portability of it, but because it's so much cheaper, it's so much easier, it's so much more instantaneous, it's faster. Our newer flavors of LANs or wireless LANs are faster than our 1 gigabit LANs. 802.11 AD, actually AC, is faster than gigabit per second LAN. USB 3.0 is faster than our standard gigabit LAN ports. And for most employees at companies, they're not even setting up desktops for them anymore. They're giving people laptops, especially if your primary job is support or customer service, or you're out in the field a lot. So access points and wireless networks are becoming much more popular. But there's some issues. Let me pass all this. I'm sure we went through this, right? This looks familiar to you guys. Do you remember that little thing? Why we use switches instead of hubs? Does that look familiar? How about this? Does that look familiar? Why we use switches instead of hubs? Or what is a switch, first of all? First of all, what is a switch? That device there. Does everybody know what a network switch looks like? Everybody probably has a network switch at home. You probably don't have a commercial network switch at home. But at your office and at U of H, here, I'll just open up a little window here. This is an example of what a network switch looks like in a rack.
Okay.
If you were to go start opening doors at Melcher Hall, you probably won't be able to get into them because they're locked, but there's a closet somewhere in Melcher Hall which has a switch rack in it that looks like this. And each one of these interconnecting devices connects to different rooms in the building and connects to different switches and different backbone networks. Actually, that's not a good example. I want to find a better example.
You can.
If I Google for MDF, what does MDF stand for? I was going to put the word network on it, not medium density fiber board. Oh, here's a before and an after picture of an MDF. Oh, there's some pretty ones. So main distribution facilities on a LAN, that's basically where all your network cabling is going to, a connecting point. And the switches are the devices that they plug into. They come usually in flavors of 8, 16, 32, 48. And they're usually rack mountable. They usually have rack ears on them. Here's an example of one that I use in my setup. Oops, excuse me, sorry. So everybody's workstation, everybody's kiosk there at U of H, if it's got a Cat5 RJ45 connection, eventually that cable makes its way into here. Usually we hit a patch panel first, a physical connecting point where the non-flexible cable that we use, the solid core cable that comes out of the walls, we connect it into that first, and then we use patch cables to feed into these things. So that's a switch. Switches, if you remember from the last class 2.5 weeks ago, or whenever we had that class, they are intelligent, but they don't require programming. They work at layer 2 only. They remember the MAC addresses depending on what's plugged into them. That's an example of a MAC table or a forwarding table that might be inside of a switch. Most switches can handle multiple MAC addresses per port. Your computer may have 2, 3, 4, 5, 10 MAC addresses, or the device plugged into port 1, there might be another switch with another dozen MAC addresses behind it. So these MAC tables are not always a one-to-one relationship. Don't worry about the different kinds of switches. Most switches are doing what's called store and forward, but I'm not going to ask that question on any test. Switching modes. I'm not going to necessarily ask you on the test what Ethernet is really called, but that's what it's really called. Carrier sense multiple access with carrier detection and avoidance. Collision detection and avoidance, excuse me. We just call it Ethernet for short because it's easier to say. It's kind of like saying 5G instead of 60 gigahertz bandwidth range for cell phone use. It's just called Ethernet. Wired Ethernet 802.11, that's the IEEE standard. 802.anything is Ethernet. What's the IEEE standard for wireless Ethernet called? 802. What? It's 802. It's right there, 802.11. There's different flavors of 802.11. There's 802.11 A, B, C, D, E, F, G. We're actually all the way up to AX now. We started over at Z. We couldn't use A again. We ran out of alphabet letters. So we went, okay, let's just use 2 letters. There's AC, there's AD, and there's AX. From this point forward, though, let me bring up this chart. From this point forward, the industry has decided we're no longer going to have this nomenclature for the naming. Has anybody bought a router or a gateway recently for their home and you bought it because you wanted a higher wireless network communication, faster speed? Anybody? No? Anybody there? Everybody there? Wake up. So
How recently?
in the last year, or like the last thing that you bought, the last wireless thing you bought, what was its type? What was its bandwidth? Was it 802.11 AC or was it just 802.11n?
I don't even know where to look for that, so I don't think so.
Well, usually when you buy them, like let's just go look at Amazon. Amazon.com. Let's go buy a router on Amazon. Okay, let's go to Amazon.com. Let's go buy some toilet paper where we're at. By the way, has anybody been on Amazon.com to price out webcams? Apparently they're tripled in price. And apparently Amazon's too busy right now. Okay, so let's just search for Wi-Fi router. Let's see what comes up. Oh, of course, Amazon's going to be pushing their own crap. Let's ignore that. Okay, so here's some routers for sale. Here's a Linksys. These numbers, by the way, they're very confusing, but usually these letters mean something. When you see AC, that means that's an AC capable router or an AC capable wireless access device. That's a pretty good price for that. That means that its maximum theoretical throughput is 6.77 gigabits per second. And then it operates at 5 gigahertz frequency, probably also operates at 2.4. That's pretty fast, but I'll tell you, you'll probably never see that speed. That would be in a perfect situation where there's no other radio interference, and you're the only one using that wireless access point, and the data that you're talking to is one physical hop away from that access point or on the same wireless access point. You're never going to see that speed. The fastest I've ever gotten throughput on 802.11 AC router is about 2 megabits per second, 2 gigabits per second, which is still pretty good. Somebody in the previous class told me they were at a Starbucks the other day and they were getting 150 megabits per second, or no, they're getting more than that. Some gigabit per second speed. I don't think that was probably true, but anyway, from now on, the new nomenclature naming is going to be just like cellular service. What's the latest cellular service phrase or marketing term out there now? What's the big thing? 5G, right? Everybody's selling 5G. What does 5G mean? It's not the same thing as, by the way, it is not the same thing as 5 gigahertz. Okay, a lot of people are getting that confused. It's not the same thing as 5G. I get 5 gigahertz. There are two wireless ranges that were set aside a long time ago in the United States by the FCC, by the way, Federal Communications Commission, as open or free bandwidth ranges that anybody could use. Bandwidth is licensed. That's why all their television stations and radio stations operate at a certain frequency range. They pay a license to the Federal Communication Commission, but no public radio stations or private operate in these two ranges because those are meant for whoever wants to use them can use them. My voice is robotic, maybe because there's some downloads going on. Am I getting robotic to anybody else? Should I speak slower? I tell you what, maybe Amazon's snooping me. Maybe I should turn that Amazon page off. Let me turn some of these things off. Sometimes, you know, when you sit on a web page, there's things going on in the background. Is that any better? As soon as you address it, it stops. Okay. Not better. Okay, hang on one second. Did I mention, by the way, Wi-Fi analyzer to this class? Everybody in here, yeah, for Android, if you don't already have an Android tablet or an Android phone, go out and find you one. You can get them really cheap, like 20 bucks for a used phone. It doesn't have to be a phone that's hooked up with anybody. It just has to have working Wi-Fi. Can't use Apple for this. an Android style phone, and you can download all kinds of cool apps like this Wi-Fi analyzer, which will help you find open wireless access points and tells you relative strength. Powerful stuff. Anyway, let me go ahead and close. I'm going to close all of these web pages. Okay, how am I sounding now? Better, maybe still a little choppy. I'm on Wi-Fi. It's getting about that time of day where the internet starts to get really, really busy. It's way better. Good. Okay, I bet it was one of my web pages I had open. All right, so here's what you need to know with respect to Wi-Fi. First of all, there's two different ranges. This has nothing to do with 802.11a or AC or N. There's two different physical ranges, first of all. I'm sorry if it sometimes gets choppy. If it gets to the point where you guys can't understand me at all, please tell me so I can stop and shake my laptop or something. So 2.4 gigahertz and 5 gigahertz. Which gigahertz range do you think is better to use? A couple of you said 5. Why is 5 better? And the answer is it depends. Depends on the environment. So it depends because 2.4 gigahertz has been around a long time. The 5 gigahertz range was released, maybe 15 years ago or so to use. You can get more throughput with it because the frequency ranges are higher and there's more waves per second. So you can get more data per second with more waves per second. But the distance is shorter, that's correct. Not necessarily just because of the distance, but because it's more susceptible to interference in the environment. I actually have a couple of 5 gigahertz backhaul antennas pointing at each other that are over a mile away from each other, and I'm getting about 6 gigabits per second between them. I'm using them as what's called backhaul bridges. And that's because they're up in the air 20 feet high, pointed directly at each other with unidirectional antennas. So, but 5 gigahertz frequencies, and the thing that makes frequencies get interfered with is the smaller the wave is, the more likely it's going to not bounce very well or not move through things very well. Nevertheless, 5 gigahertz, if you go to an open environment, like a hotel or U of H, for example, and they offer, and you can tell, and you can't always tell this, but if they offer 2 different SSIDs, you go to the Hilton and you see Hilton 2.4 and Hilton 5.0. Try to connect to the 5.0 first and see what your throughput is on that, and only go down to the 2.4 if you find that your throughput is slower or you're getting kicked off the network a lot. And that's because not just that the frequencies are smaller, but there's probably less stuff at the 5 gigahertz range. There's a lot more stuff operating at the 2.4 gigahertz range, stuff that has nothing to do with your networking, stuff that, like operates the lights in the building or the elevators, other devices in the building that were installed 20 years ago. So 2.4 gigahertz has 13 channels. I know it says 12, there's actually 13. There's actually 15, but we're only allowed to use 12 and arguably 13 in this country. 5 gigahertz range actually has about 100 channels that you can use also. Now the channels do overlap. So I'm not going to pull up a web browser again, but if you were to go look at those pictures of the examples of Wi-Fi Analyzer app, you'll see that if you were to put a device at channel 1, it actually overlaps into channel 2, 3, and 4 a little bit. And then if you operate a router at channel 6, it also interferes in maybe 2, 3, 4, and 5, and a little bit into 7, 8, and 9, but it stays far enough away from channel 1 to where you could put 2 wireless access points right next to each other, one operating on channel 1, one operating on channel 6, and they will not interfere with each other. So these devices in our classrooms, if you notice in our classroom, we actually have 2 wireless access points. We have 2 because we have as many as 50 or 60 students in those rooms, and most wireless access points physically can't handle more than 50 connections. That's a lot. of connections for one device. So we put 2 in each room. Your device connects to whichever one it thinks is the more powerful of the 2. What was I getting at with that? Oh, but we make sure that their channels are far enough apart from each other so that they don't overlap, so that one doesn't hear the other one talking. Okay. Those are the different ranges. Like I said, from now on, we're going to be calling them, oh no, maybe I didn't say this yet. After 802.11 AD, you will no longer probably hear the 802 dot anything referred to. In Ethernet, it will just be called Wi-Fi 6, Wi-Fi 7, Wi-Fi 7 LTE, Wi-Fi 8. So we're kind of going the way of cellular phone service. Well, we don't call it CDMA or GSM 16.0 or 18.5. We just refer to it as 4G or 4G LTE. So the 802.11ax, they are out there, by the way. Does anybody have about a $600 wireless access point at home? Because you're a heavy-duty gamer, like the new Netgear, which is about the size of a laptop. These new wireless access points for hardcore gamers, it's about the size of a laptop. They weigh about 4 pounds, and they have about 8 or 9 antennas on them. They're really serious pieces of equipment, but they'll handle 100 connections. And that's because basically it's like 4 access points in one. Have a bunch of antennas on it. Have a bunch of radios in it. How many of you have been to a hotel, or no, we could just use UH Wireless. How many of you use UH Wireless at school when you attach to the internet? And you don't use UH Secure? What's the difference between UH Wireless and UH Secure? Does anybody know? One of them is not secure. Or how many people of you go to a site like Starbucks where they have an open Wi-Fi, meaning there is no security, or there is no requirement to log in. They don't have to give you a password. They say, just find Starbucks Wi-Fi, get on that and surf the net. Starbucks never works for you. That's okay. Yeah, UH Secure, not only does UH Secure require a password, but they require you to register the MAC address of your device. Depending on the wireless network and what it's trying to achieve, it may have security protocols like WEP, hopefully not WEP anymore. It's very old and doesn't work very well. It's too easy to hack. Most wireless networks you get on, like your home networks, everybody in here should be using at least WPA2 for your local networking, so that the people out on the street and your neighbors don't try to get on your network. Why don't you want your neighbors on your network? What do you care? Should you care? Yeah, it slows it down. Also, they might get on your network and find things you don't want them to find, like your cameras or your baby monitors or other things that you haven't locked down at the application layer. But in other environments, like let's say you go to a hotel or a convention or a Starbucks, a lot of times they have open networks. You didn't have to, all you had to know is an SSID. You didn't have to log in with the password. Why is that allowed? And that's because they're doing the security. Either they don't care about the security because the only reason they're offering it is for you as a customer to occasionally use it, but that puts the requirement of you to make sure that you're being careful with your networking in your hands. If you don't have a firewall running on your laptop, if you don't have it on, or you're not running VPN or using something to disguise your traffic, and you're on an open network, it's very dangerous for you. Somebody can get into your computer, possibly. But in situations like with hotels, I'm running out of words for today. In situations like hotels, they want to make money off of you. Most luxury and high-end hotels. So the Wi-Fi is open, so they get you online, and then they send you to a landing page, or what's called a captured portal. You try to surf the net, you go to google.com or whatever, and you end up going to the Comfort Suites web page or the Hilton America's web page or whatever it is, and they say, thank you for staying at the Hilton. Please enter your last name and your room number. You have to authenticate some way. You're authenticating at that point up at the application layer. Go Google for what WPA stands for. WEP stands for Wireless Equivalency Privacy. We don't do that anymore. We use WPA. And WPA2, actually. I don't ask that question on the test, what WPA stands for. What I do ask is, when is it appropriate to use security and when it's not? The answer is, it's always appropriate to use some sort of security with wireless. With wired LANs, we don't really need security because our security is done at a physical layer. You can't get on a LAN, which is wired LAN, unless you know where the wired points are. In other words, if you can't figure out where to plug your cable in, you can't get on that LAN. That is the best security. When we start talking about security in the next section of this class, the lower down in the network model you can enable your security, the better. Physical security is the best. Best way to keep people out of your house is put a lock on the door, or don't have doors in your house. Don't have a physical access. The next best layer of security is to do it at the data link layer, which is what these are. All of these security protocols, WEP, which is too old and you better not be using that anymore, WPA2, and MAC address filtering. Those are all done at the data link layer. The network is not open. You're attaching it layer 2. You have to authenticate to the wireless access point you're physically connecting to before you can even pass layer 3 or above traffic. That's the best place to do it. If you don't do it there, because it's a very dynamic environment like a hotel, you do it higher up at the application layer by forcing them to a landing page, and you use proxy servers or firewalls. Also, you can enable something called AP isolation. I need you to know what that means, AP isolation. So AP stands for access point. Isolation, what do you guys think that means, AP isolation? Yes, you can record this, by the way. Who wants to record this? I have to actually enable it for you because I'm recording it too. Let's see, wait. Who else wants to record this? Ramiro, I guess I should have asked that in the beginning. I don't think there's any way for me to do that by default, by the way, otherwise I would have. Asif Siddiqui. I don't see you on the list. Where are you here? Yes, I will share the recording. Okay, guys? Oh, here you are. So I'll share it. I'll post it on YouTube. So even if I didn't get this working, challenge me, because I didn't really want to stop to do this. I probably should have asked this in the beginning. Okay, so let me just go ahead and continue. I turned on for some people, but I'd have to go down the list and do it all individually for everybody. So I'm not going to have time to do that right now. MAC address filtering, by the way, if you're in an environment where you really want very high security, you don't have wireless networking. But if you have to provide wireless networking, MAC address filtering is the next best thing to not having physical security. And that is, your network administrator has to key in the MAC address of your laptop or your wireless device into the router, into a table somewhere, either within the router or within a centralized database like we use at U of H, or you cannot get on the network. That's like how U of H Secure works. You must register at U of H, the faculty and the staff. If we want to get on UH Secure and have unlimited speed bandwidth, we have to register on UH Secure and type in our MAC addresses of our devices. Now, getting back to what the IP isolation and AP isolation is, I forgot about that. What is AP isolation? Why do you want to enable that in some situations? Anybody have any idea? Nope, nobody's typing anything. So I'm going to assume that nobody knows AP isolation. It's a feature of not every wireless access point. In fact, most of your home access points don't have this as a feature, but it's a nice feature to have if you're in a public environment and you want to protect, like you run a hotel, and you want to protect your users so that when they get on that network, they can't see each other on that local network. At layer 2, you enable AP isolation. So the only thing that those users can see is at the network layer. They can't see any of the other laptops. In other words, they can't go to click on network neighborhood and see a bunch of computers pop up in there at layer 2. They can only see basically everything past the access point that has an IP address, not everything connected to that access point. So in a public environment, Starbucks and things, for example, usually they do enable AP isolation to keep you guys from messing with each other because you don't know each other. Now, you can't guarantee that that's on, so I always recommend, like if you're in a public environment like an airport, for example. How many people use Wi-Fi in the airport? Open Wi-Fi in the airport. Airports are one of the most dangerous environments to be in, not just for physical getting sick, like the COVID virus, for example, but physically, illogically dangerous for you to use your Wi-Fi in an airport because they're all open. And it's a very transient area. People come and go all the time. And a lot of bad guys hang out in airports and just simply try to steal data off of people's laptops that have not enabled or accidentally or forgotten that they turned off the firewall on their computer. So if you're ever going to use an open network, make sure that your Windows or your Apple firewalls are on, or you're using some third-party firewall that you're using. Excuse me. You're using a VPN, which we'll talk about later. Okay, so in most LAN environments, most commercial business environments, there's an overlay of a LAN and a wireless LAN and a LAN, mostly because LANs already existed. And most companies are feverishly quickly putting in wireless access points all over their buildings to provide additional LAN connectivity, not just for mobility, but to increase the throughput on the network. The only way to solve a bottleneck in a LAN, if it turns out the circuits, is to add more circuits. The cheapest thing you can do is to put wireless access points in the ceiling. Most expensive thing you can do is run cabling through ceilings. It's difficult to do. Has anybody in here ever run cabling through the attic of a house? Or tried to cable from one side of your house to another? Well, it's not easy to do, especially if you're in a 2-story house. So this is an example of what a LAN-based layout might look like for a wireless network. You'll notice in these examples here, these little 1s and 6s and 11s, the reason that's laid out like that is because, as I mentioned before, those 3 channels don't overlap with each other. A lot of times also in a large environment like this, the wireless access points are all named the same thing. They're all named, in the case of U of H, they're all named UH Wireless or UH Secure, but there's literally thousands of wireless access points at U of H. Your computer and the protocols are smart enough to switch. Usually what your computer does is if it sees 2 or 3 of the same thing, it'll connect to the one that has the strongest signal and talk to it. And then when you move away from it, every few seconds it checks to see the connection and see whether it's gotten too weak, and it'll try to jump on the other one, the next one that it sees that's stronger. So we stagger these wireless access points, and we stagger them between floors as well. So this might be an example of a layout of a 3-story building that is an odd L shape. Also, you have the capability in most access points, and a lot of people ask me this, why do access points allow you to alter the strength of the wireless access point? Some access points are stronger than others, but sometimes you want to make them weaker. Let's say this access point in the corner up here, number 6 here in the corner, let's say it's a pretty powerful access point, but if it's too strong, it can interfere. Even if these things are on different channels, it may interfere. It may actually reach to this other number 6 here. So when you're designing a wireless LAN, sometimes we have to log into these devices and actually turn down the power. Imagine a wireless network like a classroom or a building full of classrooms, but there are no walls. Has anybody ever attended a school like that? Where you're in a classroom, which is basically just you're in a corner of a giant warehouse. No, that used to be much more common. It was called an open concept of schooling, and they started doing away with those about 15 years ago because they determined they were not very conducive to teaching. So your high school did turn into that. So some of you do that. Some of you have partitions, not real walls, but partitions. What are the pros and cons to that? Why do we do that? Why is an open concept sometimes better? It's cheaper, for one, to build a building. It allows us to resize our classrooms based on need, so we can physically make a classroom larger just by putting more seats in one corner and forcing another classroom closer to the next wall. But what are the disadvantages, and why don't they do this much anymore? And this used to happen to me a lot. I'd be sitting in one of these, because I grew up with this concept. It was much more common in the 70s and 80s. I would get distracted by the other classes. I'd be sitting in like a boring English class or whatever, and here's science class going on next door. I go, ooh, that sounds more interesting. I think I'll pay attention to that. It was distracting. So the way we try to deal with that is we try to tune these wireless access points. We try to keep them away from each other logically with those channel numbers, which essentially put walls up, and we also tune their power. Now, in large environments, here's another thing. So AP isolation, make sure you know what that means. We also do something called mesh networking. What is a wireless mesh, or what's an AP mesh? That's what we use at U of H. We use an AP mesh. And it doesn't just mean a bunch of access points in one location, all with the same SSID. Because you could do that right now. You could go down to, well, probably couldn't go anywhere, but you could order off Amazon 4 or 5 different wireless access points, put them in different places in your house, name them all the same thing. Xavier's great, 1, 2, 3, whatever you want. Name them something. Same thing. And leave up your laptop, log into whichever one's the most powerful at the time, or presumably whatever room you're sitting in. But that doesn't work really well at U of H because let's say that there is 50 people in the classroom that are all using a wireless access point that's physically close to them, but right next door there's an empty classroom with a wireless access point that's not being used at all. So you're having to share the bandwidth of this overloaded wireless access point in your classroom simply because you're physically closer to it. If it could farm off some of that, if the wireless access point could talk to the one next door, say, hey man, I'm overloaded here. Can you take some of my burden off of me? Can you take some of this load? So a mesh network allows all the wireless access points to talk to each other. They're not just talking to you, they're talking to each other. And they're saying, hey man, I got Jake and Oscar and Ramiro and Saab and Esme, we're all on this, they're all using my resources and there's nobody on this other one. And because the way laptop works is trying to connect to the one that has the physically strongest signal, it doesn't know it's to the other one. It can't know it. So mesh network devices talk to each other. They cost more. And usually they also, you also install a controller. It looks a lot like a switch. You connect all your wireless access points to this controller. The controller is the thing that decides what traffic should move over from one wireless access point to the other. And it does it seamlessly in most cases. It can also control the power of one access point. It realizes, hey, one access point, you're over in the corner there, you're getting way too loud. You're interfering with all the other access points in the building. I'm going to tune you down a little bit. You're too strong. Also, keep in mind in these maps, these are never perfect circles. It looks more like a jagged star where there's star beams coming out from it. And that's because it depends on what's in that room. Is this a big open warehouse? Or is it a library with a bunch of books in it? Or is it a manufacturing facility with a bunch of metallic things in it? Or is it a hotel room with a bunch of people and furniture in it? Radio waves don't pass through people very well. We're mostly bags of water, 80% water. So radio waves don't pass through us very well. And when they do pass through us, they do not very nice things to us, by the way. That's why most of these, your cell phones, back in the old days, cell phones were very powerful, like 5 watts. They realized, oh, we're giving everybody tumors. So now most cell phones are only about 1/4 watt of power. They're not very powerful. Here's some other devices that we use on LANs. We use sometimes load balancers, and what load balancers do is most of the time this is hardware that, like that controller I talked about on a wireless network, which can help farm some of the traffic off in one direction or another. You can do it at the network layer, you can do it at the application layer. We'll talk more about load balancers later. Virtualization. This is where we, instead of having a physical LAN, we might choose to chop up our LAN into what's called VLANs or virtual LANs based on the type of traffic that's going through that LAN or based on the physical port number that somebody's connected to. Security, we need to always have some sort of security on our LANs, particularly for wireless LANs. Physical LANs do have security, but we can do that at the physical layer. And SAN, what's that? I heard something. Somebody say something? Okay. SAN, storage area network. Here's an example of what somebody's like home main distribution facility might look like. Your cable modem and your wireless access point, or maybe this is all one device. That's a star topology LAN there. Let's talk about LAN performance for a second. We've got a server here. We've got 1, 2, 3, 4, 5, 6, 7, 8 workstations connected to this switch here. Let's say that we need to add more workstations, maybe from a different department. Maybe they're not in the same department. This switch is working at layer 2. There's a lot of traffic coming into and going out of this switch that doesn't necessarily benefit you at all. There's DHCP going on all the time. There's broadcast traffic going on all the time. And most of the time, these computers are not talking to each other on a network, are they? What are you talking to typically? You're talking to that switch and then that server there, or you're talking to that router to go to the outside world. You're not talking to each other. But layer 2 switches are basically making like a room with a bunch of students in it. And if one student talks loud enough, all the students can hear them whether they need to or not. So one thing that we do on LANs to try to improve our performance is we segment them. So if we put 2 switches into a LAN and we connect them together between the 2 LANs, essentially creating 2 LANs, we put a router in place between them that operates at layer 3, not layer 2. We've segmented that LAN. We give this LAN a particular set of IP addresses, and we give this LAN a particular set of IP addresses. So there's less of the broadcasting going on. This thing is still broadcasting layer 2 traffic, and this guy is too, but he's only talking to 4 computers, and he's only talking to 4. Only layer 3 traffic, which is not as much. If this guy here, this computer up here wants to talk to this computer down here, all that traffic stays local and it doesn't hit any of these other computers and doesn't hit that switch unless they need to talk to the outside world, like they're going to Google or whatever. Then a layer 3 or network packet gets created, goes through this device, which is a router. So keep in mind that these icons, a switch looks like a cube here or a rectangular cube with arrows on it pointing in multiple directions. This is a router. It's a cylinder with 4 arrows pointing to the center. These are industry standard icons. And when you're using draw.io, when you get to that part of the class where we're doing that assignment, which will be due the last day of class, you're going to be drawing something like this. And you're going to be choosing switches and routers and gateways and servers and workstations and wireless access points. So you need to know what these icons are. I might even ask those questions on exam 3. What's this an icon for? Router. Routers have to be programmed. So let me back up a little bit. So first of all, before I talk about some other different components on a LAN, how do we improve LAN performance? Sometimes on LANs we have what's called bottlenecks. Throughput. How much data can we get across that LAN from point A to point B or point A to point Z? We have to identify the bottlenecks. There's only 3 components of a LAN, and therefore only 3 places you can look to identify your bottleneck or bottlenecks. First place you should look is the devices. A lot of times it's a server that's your bottleneck, like in this example. If we assume that each one of these black lines, you guys can see all these black lines, right? Can you see my mouse moving? Can you see that what I'm pointing to, by the way? Okay, so each one of these black lines, let's pretend that's a 1 gigabit per second connection. If everybody on this network wants to talk to this server, he's also on a 1 gigabit per second connection. In other words, this is a bunch of 1-lane roads, and we're packing all the traffic from these 7 lanes back down into 1 lane of traffic to hit that server. So the circuit might be the bottleneck. What can we do with that circuit? What do we do to fix that bottleneck? We add more circuits. That's why servers, most servers that you see in data centers have 2, 4, 6, or even 8 Ethernet ports. So you can get a 2-lane freeway or 4-lane freeway or 8. You add more lines here, you add more physical connections to the switch. I have a switch at my co-location facility where I have one server that's connected 5 times to it because it's a very busy server. I needed a 5-line freeway, a 5-road freeway to it and from it. Sometimes it's the server. Maybe that 1 gigabit per second is plenty fast enough, but it's the server that's the bottleneck. So if the server's the bottleneck, and usually that's where I look first. I look at the server because in a lot of LAN networks, their servers are very old, 10 or 15 years old sometimes, because they were installed years and years ago. And they're not realizing that, oh, this data that they're storing on this shared hard drive, it's slow because the server's slow. So we look at usually we log into the server, and there's 3 things we look at on the server. We look at the CPU performance. Most of the time, most servers, the CPU performance is pretty low. We look at the memory usage, and a lot of times we find that the memory usage is really, really high. And that's because the servers use a certain amount of memory for what's called caching. Make sure everybody knows what caching means, disk caching. Rather than writing information to a hard drive immediately, we temporarily store it in RAM. This is what caching is. And we write it out to the hard drive when the server and when the hard drive's not that busy. The slowest thing in any network, other than people, is a hard drive, a hard disk drive. The spinning physical magnetic drive that's in your servers. And yes, I know that there's solid state drives now, but most servers don't use solid state drives. Does everybody know what a solid state drive is? Or SSD? How is an SSD fundamentally different from, that's okay. How is an SSD fundamentally different from a traditional hard disk drive? No moving parts, that's right, it's not a disk. Anytime you have to move something, that's the slowest thing you can do. If you're moving electrons, that happens literally at the speed of light. But if I have to spin around basically a disk drive is a record player. You got to spin that sucker around so that you can read the data off of it. You got a little stylus reading the data. It's slow, but they're still more common than SSDs because SSDs are expensive, especially the server grade SSDs. You can buy, has anybody bought an SSD for a laptop recently? Or does anybody have an SSD, a laptop with an SSD in it? Like it's one of these Chromebooks or a Surface. You might have as much as like 120 gig or 240 gig SSD. I bought a 120 gig SSD about 3 months ago for 20 bucks. I bought a 240 gig the other day for 32 bucks. Very cheap. If I were to buy a 240 gig SSD drive for a server, it would cost me $1,000 bucks. There's huge differences, and that's because consumer grade SSDs are made with not very good chips. 5 years ago, 120 meg SSD, 120 gig cost 80. That's still even a really good price for 5 years ago. But they're very expensive for servers, and that's usually because the hard drive of your workstation is not getting written to that often. It's getting read from, but not written to very often. So yeah, you can buy the $100 drive for about 25, 30 bucks now. Some of them are fake, so be careful, by the way. They might say they're 200 gig, but they're really only 30 gig. Kind of like the fake USB sticks. So there's another thing that we do on servers to speed up our disk access, if that is our bottleneck. And by the way, we find these bottlenecks by looking at the performance numbers that all server software puts out. RAID. What is RAID? Different flavors of RAID. Let me skip ahead here. Oh, that was it. No. I thought it had RAID in here. Oh, it's probably in the next chapter. That's okay. Let's just finish this up and I'll talk about RAID in just a minute. So we're almost at the end of this chapter and I'll jump right into chapter 8, which is a real short chapter. We look at the devices. A lot of times it's not the devices if it's a relatively new server. Also, where do we store most of our data these days for networks, for LANs? Most of our customer relationship information. It's not on a local server anymore, is it? It's on the network. It's on the internet. Not the network. It's on the internet. So our backbone, our WAN connection, our circuit to the internet is usually our bottleneck. So in servers, we can upgrade the server by adding more CPUs, adding more memory. That's the first thing I do, by the way, when I have a company that complains to me that their server is slow and they want to replace the server. I say, let's not do that. Let's just add more memory. And 99 times out of 100, adding more RAM to the server if there's space for it. If it has capacity, speeds up their server access. Or we put in RAID, which stands for redundant array of independent or inexpensive drives. So I'm going to open a browser real quick, and I want you to make sure you know, because you will need to know this for the test. Doesn't go much into it in the book, but in terms of fault tolerance, and we talk about this more in the third section of the class, but you better start learning it now. I don't know if I can open this or not. Oh, it's underneath this. I have to stop sharing this for just a minute. Okay, if I just Google for it, and you can Google for this too, the RAID. First of all, what is RAID? RAID is redundant array of inexpensive disks. It's basically where we take 2 or more hard drives to represent our data. We don't put one file on one drive and one file on another drive. We literally put 1 byte of a file on one drive and another byte of that same file on another drive. Or we put 4 bits of 1 byte on drive A and 4 bits of another drive on drive of another byte on drive B. We split up the data. That's called striping in the case of RAID 0. We take 2, 3, 4, 5, 6, 10 disks and we stripe the data across those disks. If we used 8 disks in a RAID 0, for example, there might be 1 bit per disk. And the access would be much faster because it's a lot faster to read 1 bit off a disk than it is 8 bits. So if you can read all 8 bits off of 8 disks at the same time almost, the access is going to be much faster. Now, RAID 0 is not used very often anymore because if you lose 1 disk, if the RAID 0 disk array, if 1 disk in RAID 0 dies, the entire data, the entire disk array is gone. Your data is gone and you have to go to backup. So what we see these days is either RAID 5, which is not as popular anymore. That's where we basically take 3 or more disks. It's not 5 or more, but it's 3 or more disks. And we do the same thing that we do with Ethernet, where we create a check digit. We store that check digit on that 3rd disk. We need 3 disks. So if you bought, like, for example, 3 1 terabyte drives and put them in a RAID 5 array, you could store 2 terabytes of data. Hang on, I lost my chat window. Yeah, there's some things about how much does RAM in a server, how much RAM does a server usually have? Somebody asked. Well, that depends on what the server's doing. I recently upgraded some servers in my data center and I added to most of them 256 gigs of RAM. One of them has 768 gigs in it. It's capable of taking 1.5 terabytes of RAM. Do you know how much 1.5 terabytes of RAM costs for a server? I could have bought a car with that. So it's pretty expensive. Yeah, at least $10. Good guess. Basically, it's $10 per gig. It's pretty expensive. And if you buy used server RAM, it's cheaper, but we try not to buy used server RAM. It's more expensive than workstation RAM. It costs about twice as much. So RAID lets us basically take, and I'm not going to ask you to know very specifically what RAID is, but I do want you to know the difference between RAID 0 and RAID 5 and RAID 10. RAID 0 has at least 2 drives in it, 2 or more. There's no fault tolerance because all the data is simply striped. RAID 5 is where you have some fault tolerance. You can lose 1 of the 3 or more drives and you still have the data's there. You have to use special controllers, and you never do this on workstations. Most workstations can't do RAID because they're not designed for it. Most servers can do RAID, but you have to have special RAID controllers or special software. I use RAID 10 on my servers. You use at least 4 hard drives, and they're in 2 pairs of 2. So at least 4 hard drives. I use RAID 0 on the first 2 drives, and then I mirror that to another striped array of 2 drives. So if I can lose up to 2 drives in that RAID array, but it takes twice as many drives. So I lose 50% of my drives when I do that, when I create RAID mirroring. So it costs a lot, but it's fault tolerant, meaning I can lose 1 or 2 disk drives in a RAID 10 and my data is still alive. I don't have to restore it from backup. And in most servers, the drives are hot swappable. What does that mean, hot swappable? That should be pretty self-explanatory what that term means. If something is hot swappable, means you can swap it while it's hot, swap it while it's on. It's really cool to be able to walk up to a server in a data center, push a button and pop out a hard drive, put another hard drive in, and 10 minutes later, it's rebuilt itself based on the rest of the data in the RAID array. That's what we do in data centers. Almost all servers have front-loading hot swappable drives. Push a button, the drive pops out. When a drive fails in a server, usually a light starts blinking or you get an email. Isn't that pretty cool? Wouldn't that be great if you could do that with your laptop? Your drive starts failing. Now everybody thinks SSDs are great, right? Has anybody ever had an SSD fail? Solid state drive fail? Why isn't the whole world on SSD yet? Yeah, not yet. Your consumer grade SSDs, that 240 gig SSD I bought for 30 bucks, if I'm going to put that in a workstation. But I'm going to back that workstation up because one of the major differences between SSDs and standard hard drives is a standard hard drive will slowly start to go bad. It'll start warning you. First of all, you'll hear it. Anybody ever have a hard drive start to go bad so it starts getting louder and louder and louder? Anybody have a car that starts to go bad, so it starts getting louder and louder, or it goes slower and slower, or lights come on the dashboard, or it starts smoking, but you still drive it for a few more weeks because you got to finish out the semester or whatever. Or if I can just get this piece of crap, Volvo to last me to the end of the semester, then I'll get a good job and can leave. But with solid state drives, it's either all or none. They'll fail immediately. And a lot of times they don't fail till you turn them off and back on. So I've had laptops where they have a solid state drive in them. I'm using them. I turn the laptop off, come to turn it on 2 days later, drive has failed. So you got to be careful with solid state drives, especially as consumer grade solid state drives. If you do a lot of writing to the drive, save a lot of information to the drive, it will severely shorten the life of the drive. Solid state drives, depending on what you do on them, their lifespan can be as low as a year. Okay, so back to this. As I mentioned before, circuits, what can we do with circuits? Sometimes we're fortunate enough to where we can actually upgrade the physical circuit itself. That usually only works in the case of a wide area network connection. Usually on LANs, we're already operating at the fastest possible speed. Unless it's like a backbone network where we're connecting 2 or more servers together and we replace the copper cabling with fiber cabling, for example. But usually what we do to upgrade LANs when the circuit is the bottleneck is we simply add more circuits. as I mentioned before. We add more wires. Or we add access points. That's the case of where I was talking about, where we simply put a bunch of wireless access points in different locations, and we tell people, well, use the wireless network instead of the wired network, or use both. A lot of people's desktop computers, newer desktops, have both wired and wireless, and you can connect to both at the same time, and your computer is smart enough most of the time to use either one of the connections in a round robin fashion, or in a least used fashion, where some of the packets will go out one connection and other packets will go out the other connection. Or you can segment the network, which is what I showed you already before, segmenting a network. Okay, this is the end of this chapter. I'm going to hop into chapter 8 and just mention a couple things in chapter 8. Know these terms also. So all the terms I've mentioned so far: hot swappable, RAID. If I went a little too fast, go type these things in a WordPad document or a Notepad document and go Google them later. Make sure you know the difference between RAID 1, RAID 5, and RAID 10. Make sure you know the difference between hot swappable and not swappable, or hot and cold hard drives. The difference between a hard drive and a solid state drive, and why we don't see solid state drives that often yet in servers. And that's because, like I said before, the more writing you do to the solid state drive, the shorter its lifespan. You can think of a solid state drive kind of like a paper clip. You know, you can take a paper clip and bend it up into a straight line, right? And then you can bend it back into a paper clip. Anybody ever do that when they're bored? Unbend a paper clip and bend it back. What happens if you bend a paper clip 7 or 8 or 9 times? Bend it around. It snaps, that's right. So does the memory in your solid state drives. Eventually the electrons can't bend back and forth, and it's not exactly that, but that's a good analogy to think about. If I keep bending the paperclip back and forth, eventually it'll lose its bendability and snap and won't work anymore. And that's what happens inside your solid state drives. So know these terms. Enterprise, make sure you know what an enterprise network is. It's a network on the Starship Enterprise. No, that's not true. It's a network that comprises your entire organization. Most LANs are not enterprise based. Most backbone networks are enterprise, but not most LANs. But we use that term enterprise equipment to refer to intelligent or managed network devices that work at layer 3 or higher. SOHO, what's that term mean? If you're from New York, it means south of Houston Street. But in the networking world, it means small office, home office. So right now, everybody is in a SOHO network environment because we're all sitting at home on our laptops. Hopefully nobody's at a Starbucks right now coughing on each other or drinking after each other. SOHO networks are getting more popular because of, not just because of this COVID-19 thing. A lot of you were already working at home or had the ability to already work at home because it is more convenient. There's a lot of advantages for us to be working at home. What are some other advantages to working at home? Maybe you guys haven't recognized them or realized them yet. How many of you are not wearing shoes or pants? Or I don't need to know that, but I mean, I could be wearing no pants. You don't know. Or no shoes. I promise I'm wearing pants because, you know, I had to get up. But all I had to do is dress from the neck up and I look good. Or I don't have to turn on my video at all. And we could still have a virtual face-to-face relationship. It's cheaper, sort of. Yeah, it has gotten cheaper. It's certainly in terms of time. In my world and in most people's worlds, the most expensive thing you can do is what? Move around. Yeah, waste time by moving around. That's the most expensive thing that any of us do, is moving. If you don't have to, and I'm not talking about moving from one state to another. I'm talking about literally getting in your car and driving somewhere to do your job. If you could do your job from home, all you got to do is get up. Don't have to take a shower because you don't have to worry about working with the people next to you. We don't have virtual smelling yet. So yeah, get to spend more time with your dog. You're probably spending time with your dog right now while I'm talking to you. So lots of advantages to SOHOs. What are the disadvantages to what we're doing right now? Are there disadvantages? Distractions, that's right. Like, so Jake's dog is distracting him right now. Or your kids are distracting you. Or the connection's not very good because it is a home office. So it might be your connection, it might be my connection, I don't know. That's another thing, yeah, the support, and that's the hugest issue that U of H is dealing with right now. How does the support and help desk support us as professors and you as students? We're no longer using the U of H network anymore. You work for IT support. So yeah, it'll be a difficult challenge. It's going to be mostly a bunch of on the phone stuff. So yeah, it's rough. Some students, some people don't have the technology that they need. Like I said, and I got a text from my stepmother earlier. Hey man, can you get me a camera? And I said, well, you just buy one on Amazon. She said they've tripled in price because of what's going on. So I tell you what, why don't we do this? Let's not even get into chapter 8 right now since it's 5:15. Let's just finish talking about this because these are interesting things to talk about. And I'm a little bit ahead in the previous class, but that's okay. I wanted to talk more about this, working from home thing. IoT, that last thing, not OIT, IoT. The Internet of Things. So could somebody tell me what that means and why it's influencing land design, the Internet of Things? Don't Google it if you're going to give me an answer. Try to see if you can guess or if you already know. Things connect to the cloud. Be more specific. Why should things connect to the cloud? Yeah, it stands for the Internet of Things. Why is that a thing? Why is the Internet of Things a thing? And why are companies and consumer organizations or companies that build consumer devices, not just for business, but for home, why are companies building all these devices that have Wi-Fi built into them? Big web of connected devices. Automation, that's one. That's actually not the most important reason for consumers, but that is a very important reason for businesses, so that I, as a physical plant manager, for example, can monitor and control my air conditioning systems, my lighting, my doors. If you've noticed, by the way, on Melcher Hall, the reason Melcher Hall is essentially open is there are no locks on the doors. If you walk around Melcher Hall next time you happen to be on campus, look for the locks on the doors. There's no locks on any of the external doors anymore. There are physical locks, but they're controlled by a magnetic device, which is controlled by a program in a database. So the building people, the cleaning people, the maintenance people, they don't have to remember to lock doors on the weekends to keep people from stealing stuff. They just push a button on a keyboard, or it's automated. It's a program that's running that says at 7 p.m. we're going to mag lock all the doors, for example, or 10 p.m. or whatever it is. But yeah, it makes things more efficient, because what did I say just a few minutes ago? What's the most expensive thing that humans can do other than eat? That's pretty expensive. At least it's expensive when I do it. Anybody get their $5 pizza from Domino's yesterday, by the way? They ended that 50% off deal. I bought 4 pizzas and put 3 of them in the fridge. Moving. So if I don't have to have my plant managers and people physically moving around, if they could sit at a keyboard anywhere in the world, their job is more efficient. Also, they don't have to be employed by me. They can be in a data center in the Philippines or India, where I'm paying the FTE equivalent of $5 an hour to do a job that would have to pay $25 an hour to somebody here. Anybody had to call Comcast or AT&T recently and talk to somebody? They're in the Philippines. And we can do that because all of our telephone conversations are all now on the internet. What are some other reasons why we Internet of Things, IoT? And by the way, Microsoft did not invent it. They claim they invented that term. They did not invent that term. What are some other good reasons why would I want to add Wi-Fi to my appliances, to refrigerators, or to cars? Clap on is an IoT thing? Okay, yeah, sure. He's talking about a clap on the clapper. Sort of, not really. You can't clap across the internet, can you? Although somebody's probably developed a clap-on gateway. What are some other reasons for IoT? And that'll be the last thing I talk about today. How about in terms of, let's say you're a company and you build appliances, you build refrigerators, and you build washing machines, and you build cars. Sell more updates. You're getting there. You're getting there. It's not for you. Yes, that's the answer. To collect data, to collect usage, so we know how often you're using your refrigerator, how many times you open the door, how often you're using your washing machine. Are you changing your filter? Oh, it's been a few months. Your filter needs to be replaced. Let me send you an email with a coupon in it to go, yeah, oh, that's scary. Roomba's collecting maps of people's houses. That's possible. Hopefully they're not doing that, but that's possible, so that I guess they can sell that data. But who said collecting data? Andy, that's the real answer there. The real money that can be made right now in the world is selling your data, big data, selling your data so that you can sell those trends to marketers, to people that need to market their goods and services. What should we be selling to people? I don't know. Let's see what the surveys say. Well, nobody takes surveys anymore because nobody answers survey calls, and all the emails that we send to people, they try to send them to, they go to spam mailboxes. Does anybody do surveys, by the way, when they install software, or are you good and you ignore all those? You should ignore all of those. Yeah, don't help them. Whenever Google says something like, hey, we're going to give you this free tool, make sure you always uncheck those little boxes that say, do you mind if we send some anonymous usage data back to our servers for not for marketing, but for research purposes? It's for marketing. They're collecting data on you. That's the money. If a company who makes refrigerators can develop a database of usage and then turn around and sell that to a company that builds filters, or that does refrigerator repair, that's another income stream. Tons of income streams. So, oh yeah, that's another thing that people believe that, or people don't believe that. Anybody in here have an Amazon Echo or an Echo Dot or one of those little things? Supposedly, and I think this is true, supposedly those things are listening all the time. The reason I know that they're listening all the time is I have some in my house, and I'll be talking to my girlfriend or whatever. Hey, it'd be nice to go to Las Vegas for spring break, blah, 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 whatever. And then I get on my computer 30 minutes later, and guess what's popping up in my feed, in my Google feed? Ads for Las Vegas. What the hell? How did they know? It's because they're listening and they're selling that stuff. Yeah, use a browser, or use your browser in incognito mode, or live under a rock. Yeah, well, there's pros and cons to it. I choose to live out in the open because it's more convenient for me to do so. Also, I'm not a freak, and I don't do things I don't want people to know about and stuff like that. So I don't care if a lot of people know things about me. I don't care that companies market that stuff to me. In fact, sometimes it's useful. I got some good deals. I stayed at Caesars for free basically while I was in Las Vegas because it popped up. I didn't know where I should stay. So some of it's true, some of it's not. Some of you sound a little conspiracy theory-ish, but there's more of that going on than people realize. Another thing, the thing that we're doing right now. Do you think they're listening to our conversation? People are listening other than you guys? No, they're not listening, but there are programs listening. There are programs that are listening to our voices and listening what we're talking about, or maybe they're just using this Zoom program, this Zoom teleconference, to improve their voice recognition software and their AI software, which they can then go sell to other companies. Google does that all the time. And when you use the Google Voice Assistant, and presumably Siri as well, they're using that to make their product better. That's good for everybody, but you know, a lot of people don't realize they're doing that. Some people might want to opt out of it. The FBI guy, yeah. So there's no FBI guys listening to us. That's where the conspiracy theorists come in. They think the FBI's after them. You think the FBI really gives a shit about what you're doing or what I'm doing right now? No. They're busy trying to keep COVID-19 out of our country. Right, that's exactly right. The FBI, bear in mind, the FBI is also the same organization that runs the post office, the federal government. So yeah, it's funny, but there's too many conspiracy theorists out there. But it's big business that's really using all of this data. So I'm going to leave you guys with that. Go Google for those things that I mentioned in the notes and in the little chat session here. IoT, SOHO, enterprise LAN, RAID, the other things that just scroll back up through this chat session. Look at these things that I typed in. Also, remember to shoot me an email. You don't all have to do this, but I would like some feedback as to whether teaching the class this way is going to work for you, or whether you have some suggestions or ideas or criticisms. Yeah, that sounds pretty good, Ramiro. All those things. And what else? Scroll back up. Look at the PowerPoint presentation. Also, make sure, like I said before, that you are using and looking at the notes for each chapter. Let me just go to my project.com page. I'm going to not go to, no. I have this old legacy site, project.com, which basically has my stuff on it too, by the way. Overview and general syllabus. In the chapter 7 section, for example, I have both my own notes and the book's notes and the PowerPoint presentation. I only ever show you guys the PowerPoint presentation, but make sure you're also looking at that chapter outline and notes too, because it'll have these terms in there and it asks these same kinds of questions. This is a whole bunch of, there's the SOHO, there's RAID, there's POE. I didn't even talk about that today. I talked about that, I think, 2 weeks ago. There's the chapter outline. And then there's several questions at the end of each one of these, which some of them are similar to what I'm asking you, some of them are different. But go through these questions and ask these questions of yourself. Do a little bit of research on your own to help you understand these chapters better and the material that we're talking about. So does anybody have any comments that you want to speak out? Unmute your mic and say anything. Let me stop sharing there. Okay, well then what we'll do is, like I said, send me an email with some criticisms and some suggestions. Let me know what other professors are doing. We're all doing different things. Some of us are using Zoom, some of us are using Google Meetings. We are not, we haven't been forced onto any one particular platform. That's because we all teach different things. Some of the profs are doing different things. Dr. Parks, like somebody said, is recording all of his lectures. I can't think of a more boring thing to do. How do you receive the recordings? That's a good question. I don't know yet, because like I said, I have to research the best way to make the recordings available to you. I probably will just put them on YouTube. And if I get enough views, I start getting money. So, hey, cool. So tell all your friends, if I get 10,000 views, I get a penny. All right, if I get, what is it, 100,000 views, I get $1. Yeah, so maybe I'll create a YouTube channel. Who knows? We'll see what happens. I don't know if what the maximum size is, because this is the first day I've been making recordings. This could be a 2 gig file or a 20 gig file. I have no idea. I think because everybody else has their video muted, or most people video muted. Is that why I can't see you? Can you guys turn on your video so I can see or not? Okay. So I think probably because most of you don't have your video on, it'll probably be a pretty small file, I would think. And I don't even have to turn my video on. We just need the audio. You're too ugly to have a webcam. That's not true. You're not too ugly. So anyway, I will see you guys on Wednesday. We'll do the same thing, same time. If you want to attend the 2:30 class, I kind of do the same thing at 2:30. And good luck. Stay safe, everybody. Don't go anywhere unless you have to. See you Wednesday.